Alrighty, we're going to start solving equations, and nice try. Tried to get me on a tripwire. So the equations are going to be no calculator equations. So they're going to all work out to be pretty friendly problems. All right, so let's get started. We have the log of 27 base x equals 3. So how are we going to, Sid, you have a visitor. How are we going to do that? How do we solve that? We could subtract 3, but that's not going to really get us anywhere because we don't have, like, in the quadratic ones, we set those all equal to 0, right? But that strategy is not going to work for logs. So, other thoughts? What? Cube root 27, maybe. How did you come up with that? Maybe some of you are just looking at this and thinking about it in your head and thinking about what does that mean? So what does a log mean? I just was talking to this with Sydney about it. Yeah, x to the third power is 27. So if you rewrite it in exponent form, then you can get a feel for what we're talking about here. So what number, when you cube it, gives you 27? 3, okay? It might not be that easy of a number, so how would we undo? Let's think about this in a little more specific terms. How would we undo to the third power? Cube root. And I'm going to write cube root as a fraction because it's going to be more useful for other scenarios. So if I cube root or take both sides to the 1/3 power, in this case, that will give me x to the first. So that'll get rid of my power on the x, and I will have x all by itself, and x will equal the cube root of 27, which is 3. Yeah? What do you think about that? Right, so oftentimes you're trying to solve an equation with a log in it, and maybe you don't know what to do. Rewrite it as an exponent, and then maybe a light bulb will go on. Oh yeah, now I know what to do. Okay, let's try the next one here. What do I do? Rewrite it as an exponent. X to the negative half is equal to 4. So something to the negative half power is 4. Okay, well that one's a little harder to just think about. Let's just do the inverse of to the negative half power. So what would get rid of to the negative half power? So that the idea here is, because okay, so we've done the whole, what's the opposite of squared? Square root. What's the opposite of cubed? Cube root. Okay, now it's like, what's the opposite of negative half power? So what's really happening when you're doing that cube root stuff is you're taking it to the reciprocal power. So the reciprocal power of negative a half is negative 2. If you take both sides to the negative 2 power, then you're going to get x all by itself. You'll undo what's happening to x there. So the inverse of to the negative half power is to the negative 2 power. That gets me x all by itself, x to the first, and 4 to the negative 2 is going to be 1 over 4 to the positive 2, which is 1 over 16. Ka-chow. What do you think about that? Students in the back? Yeah? If you have a question as along the way, pop in there, ask that question. Don't just sit back and go, well, voice those thoughts, voice those questions. Yep.
So you just take the reciprocal but not the opposite, so the exponent stays negative?
Great question. You keep the sign the same, yeah. So a reciprocal always has the same sign because a number times its reciprocal is always equal to positive 1, right? So if you have like negative 2/3, the reciprocal of that is negative 3/2. Because when you multiply a number and its reciprocal, you always get positive 1, right? Yep, so keep the sign the same when you're doing the reciprocal. Alrighty, keep plugging away. Next one's a little different. We got this 2 out in front of here. And we just got done finished doing the properties section. So what can you do with that 2 if you want? You could put it as an exponent, right? If I put it as an exponent, then I'm going to get x squared, and I don't really, if I can avoid that, I'm going to. So I'm actually not going to do that. I'm going to divide both sides by 2, since that's all I have is like the 2 times a log equals something else. It's not like I have plus a whole bunch of other stuff and I have to multiply 2 by all that other stuff, you know? So I'm just going to divide both sides by 2, or divide by 2, all that stuff, I mean. So that'll get rid of the 2. So now we have the log of x base 3 equals 4. So now we're missing stuff. The unknown is the stuff part. You take this and you just rewrite it. Yep. 3 to the 4th power, write it as an exponent, equals x. All we have to do is evaluate that. 3 to the 4th power is the same as 9 to the 2nd power. 81. 81. You're right, 81. This is a golden sheep. Turtle. Sheep.
Oh
See those turtle? Have you ever seen a big snapping turtle? I've seen a huge snapping turtle before, like the size of this desk almost. They're scary, man. We actually had to capture it. It was on a job. We were mowing lawns for the school district in Burnsville, and there was like Project Kids. It's like Kid Ventures or whatever. And there was this huge snapping turtle, and there's all these kids around. And my buddy that I'm with is much braver than me, and he circled it around behind it and picked it up and threw it in the work truck. We were going to transport it to a different area. You know, a catch and release program. He just set it in the back of the work truck. And we went to lunch. And we came out of Subway, and the turtle was gone. It had gone out of the truck. I can't believe it. I didn't think that turtle was that athletic. What? I doubt it. I can't remember now that I think about it if the turtle was like right on the ground by the truck when we got out there and we had to pick it up again. I think that's what happened. I think the turtle, and then he had to get it again back in the truck, and then we brought it back to the pond where it lived, and we let it go. But that turtle went for a ride. I mean, what, around town? It's probably freaking out. Well, we did. We put it in the bucket. We put it. It was dangerous. It was a danger to the children. All right, continuing on after the oh, by the way, we also named the turtle. His name was Dragor because it looked Dragor, Dragor. Yeah. All right, back to the lesson here. We have another missing stuff. This one isn't too bad. 3 to the negative 2nd power equals x. You guys know what to the negative 2nd power is? 1 over 3 to the positive 2 power. Take the reciprocal, make the power positive. 1/3 squared is 1/9. There we go. All right, next page. Any questions? All right, a little different scenario here. We have log of x plus log of some other stuff. And so now we can employ the properties we learned yesterday. We can take those 2 logs that are added together with the same base and make them into 1 log. So here we have the log of x times x minus 21 is x squared minus 21x. Whoops, there we go, 21x. Equals to, what's the base? If the base ain't there,
You like distributed the
10. I'm taking x times x minus 21, and so to do that, you have to use the distributive property. Yep. Now it's a base of 10, common log. Rewrite it as an exponent, and you're going to end up with 10 squared equals the stuff, which is x squared minus 21x. 10 squared, I know what that is. That's 100. So how do we solve a quadratic equation? Well, set it equal to 0 if it has like 3 terms, you know, like a trinomial. If it has x squared, x, and a constant term, we have to set it up, try to see if it factors. So set it equal to 0. So we'll have x squared minus 21x minus 100 equals 0. Hopefully it factors. If it doesn't factor, we'll have to use our quadratic formula. But this one factors because factoring is the best. Love factoring. I get a book mailed to me every year, Factoring Trinomials. It's like crossword puzzles. There we go. X minus 25, x plus 4, it factors. Woohoo! Okay, what are the possible scenarios here now for solutions? We got 25 and we have negative 4. Now this is where you got to be a little careful. We're going down a little bit of a slippery slope here. With logs, this has not come up yet, but we can have some extraneous solutions. So we have to check for extraneous. Because with the negative, you might have a situation that's sort of impossible, like this negative 4. If I put negative 4 in for x, there or there, that's like saying this here now. That's like saying, hey, the log of negative 4 base 10. Okay, and if you think about that as an exponent, that's like saying 10 to what power equals negative 4? You can't take a positive number like 10 to a power and ever equal a negative. So it's a bogus answer. It's extraneous answer. So this answer, negative 4, is actually not an answer because it makes the stuff negative. But 25 is okay because that doesn't make the stuff negative, so we're good. So you got to check for extraneous, make sure that none of your answers make any of the log stuff negative. Okay. Get rid of that because we need the space. Next, any questions on that or next question? Next one. Okay, next one, we have 16 to the whatever to the x. What can we do with this? Any thoughts? No, you can't divide by negative. Wait, what did you say? Divide, multiply. What did you say? Multiply by 64? But you can't do that because this is to the x. So like if you multiply by 64 on both, well, you could do that. I guess I shouldn't say you can't do that, but you have to evaluate the exponent before you multiply by 64. So it's not going to be able to cancel out that 64 because that x is there. Yep. So that'll actually make it more difficult. Hi. Yeah, we're recording live here. And I told the story about the turtle, Dragor the turtle. Remind me, I'll tell you guys at lunch someday. It's a thrilling story about a dangerous turtle named Dragor. Dylan?
Would it be negative
Ooh. Dylan's figuring this one out in his head. You can actually just reason your way through this one. Okay, think about this. How can I turn a 1 over 64 into a 16 by taking it to a power? Well, if that power is negative, it flips it, right? And then if I take 64 to the third root, cube root, I get 4. And then if I square it, I get 16. So some of you might be able to think about and reason your way through with your knowledge of exponents, but that's always not a very reliable strategy. So what's another strategy we can use to make some progress or have some structure to solve this problem? If we rewrote it as a log, it would be the log of, let's see, 16 base 1/64 equals x, right? And that would be all fine and dandy if we had a calculator, but this is the non-calculator part. Oh, non-calculator part. Wah, wah, wah. If it was calculator, we could just plug this in. Log of 16 divided by log of 1/64, and we could get our answer. But we're going to do that on Monday with the calculator stuff. So that's not really going to get us anywhere. That's going to get us back to where we started. So there was another strategy we used. You remember it, Lillian? Aha, good. Yes, very good. We can get them to have the same base. So if I rewrite these with both the same base, 16 is a power of 4, that's 4 squared, equals 1 over 64 is a power of 4, that's 4 to the negative third. And so if I rewrite them with the same base, now we're in business. 4 squared is equal to 4 to the negative 3x. Bada bing, bada bang, bada boom. When is 2 going to equal negative 3x? That's just a simple little equation. You might want to write it out actually to solve it. Negative 3x equals 2. Divide both sides by negative 3 so you don't get an upside down answer. X equals negative 2/3. That was a neat little problem that not many people in the world could probably solve. This video is brought to you by V8 Original. 2 servings of vegetables in each can. I got a email from Google saying, yep, no, I swear, saying you can't have a branded account or something, blah, 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 on this school email domain. So they're threatening to delete all my stuff. Yeah, because they think I'm making a brand like Mr. Bolio, like the next Danny Duncan or something. The heck? I protest. In this video, I here protest this revocation of all my intellectual property, whatever it is. No, I don't monetize. I ain't selling out, man. No one's gonna sit through any stupid ads on my videos. That sip of V8 was delicious. It probably will. They probably are listening to it right now. They're recording everything, and now all of a sudden a V8 ad's gonna pop up on my phone later. It's creeping me out, dude. All right, let's wrap this up. Sorry, I'm kind of talking on tangents today. We can use the product property to get this down to 1 log, right? And we distribute, Aaron, x squared plus 2x. Okay, and then that equals log of 3. This one's a little different because now I have log equal log. So, well, you can't really divide by log because log really isn't like a number. But you could use this sort of strategy that we used right over here with like 4 to some power is equal 4 to some other power, set the powers equal. This is like the log of some stuff is equal to the same log with the same base of some different stuff. So this is going to be true when the stuffs are the same. So what we're going to do is we're going to just, when we have log equal log, we can just drop the logs off. Okay, so log equal log. If they're the same base, you can just ignore the logs, get rid of the logs, and solve for whatever you have. Pfft, crapes. So now we have x squared plus 2x is equal to, wait a minute, was it 100? Oh, that crap erased right there. This is the log of 3 it was. So equals 3. Right, so I dropped the logs. I have that stuff equal that stuff. I'm going to set it equal to 0. This is a happy little quadratic equation. It's going to factor it up. Bada bing, x and x. Factors of 3. Let me think real hard about this. Oh, factors of 3. Oh, 3 and 1. They're the only ones. All right, so 3 and 1, that's going to be a plus 3 because I want more positive to make the middle 2, and a minus 1. And so my two potential solutions are negative 3 or 1, but you can't forget to check for extraneous. So check extraneous. Extraneous. Okay, not extraneous, what Staub says. All right, so it's extraneous. And which one's not going to work here? I think negative 3 is not going to work. Negative 3 crossed out because negative 3 is going to make that the log of a negative, and that's impossible. So final solution for all you turkeys at Google who want to hold me down, man. I'm canceling my YouTube TV subscription that Gala pays for. All right, signing off.